Hello, welcome to another video from Module 1 of our Networking Fundamentals series. This module will teach you everything you need to understand how data flows through a network. This is Lesson 6, where we will unpack the idea of networking protocols and give you a brief description of a few important protocols you should know about. Now, we've actually used the term protocols a few times in this course without giving you a formal definition, and I'd like to start there. A protocol is simply a set of rules and messages that form an internet standard. For example, we've discussed the Address Resolution Protocol, or ARP, in this course. We've told you that ARP resolves IP to MAC mappings. This allows two hosts to discover each other's MAC address if all they know is their IP address. They do this by sending out an ARP request, and the receiving host sends an ARP response. The key, though, is someone had to determine what an ARP request looked like. What question was asked in the ARP request, or what information was included in the ARP request, or what to add as the destination MAC address in the ARP request. In the same way, something had to decide what an ARP response looked like. Well, in the case of ARP, that set of rules is defined by RFC 826. You can actually look up RFC 826 to see the specific rules for what actually makes an ARP conversation. The RFC are the engineering implementation guidelines for how to do ARP. This RFC has all of the rules that govern what an ARP request is and what an ARP response is. And the fact that these rules are published as an internet standard allows ARP to be implemented by many different vendors. That's what will allow a HP server to speak to a Apple MacBook, or a Dell laptop to speak to a Samsung phone. All of these different vendors are simply following the public open internet standard for ARP, and that's what allows them all to speak the same language when they are doing ARP with one another. That is the definition of a protocol. Again, it's simply a set of rules and messages which create an internet standard. Just like ARP is an important internet protocol that you should know about, there's a few other internet protocols that I'd like to introduce to you, starting with File Transfer Protocol, or FTP. FTP allows a client and a server to send and receive files from each other. The FTP conversation is made up of messages that look like this. The client would send the RETR command, which stands for retrieve, and ask for a particular file, and this would prompt the server to respond with that file. There's also the SMTP protocol, which stands for Simple Mail Transfer Protocol. This is the protocol that email servers will use to exchange emails. That conversation looks like this. The client will send the hello command to an SMTP server. The SMTP server will then respond with a response code of 250. And now the client and the server can exchange emails with one another. Hello and 250 are simply some of the messages in the SMTP standard. There's also HTTP, which stands for Hypertext Transfer Protocol. This is the protocol you're using anytime you're communicating with a web server. Web servers host many web sites written in HTML, which stands for Hypertext Markup Language, and those HTML pages are exchanged using HTTP. When you browse to site.com, your client, your web browser, is sending a GET request to the web server, and the web server will respond with a 200 OK message and then provide the website you're asking for. There's also the SSL and TLS protocols, which allow a client and a server to build a secure tunnel between themselves, and then they can do that HTTP conversation within that tunnel. That process is what's known as HTTPS. That is in fact what HTTPS stands for. It's an HTTP conversation secured within an SSL or TLS tunnel. That's what allows you to browse the web securely. So that's a quick rundown of some of the important protocols that exist on the internet. There are thousands of protocols out there, and all of them contribute to some sort of functionality in the internet ecosystem. And there's two more rather important ones that I want to talk about, but first I want to focus on the host for a minute. In Lesson 1, we told you that a host is anything that sends or receives traffic, and that hosts are typically divided as clients or servers. But we also said that a server is really nothing more than a computer that knows how to respond to specific requests. Meaning each of these servers are really just computers that have FTP software installed, or SMTP software installed, or HTTP or SSL software installed. Which means These clients and servers all follow the same rules of host-to-host communication that we unpacked in Lesson 3. And one of the key elements of that is for a host to speak to another host, it must know the other host's IP address. Now this will work for this client to speak to the FTP server because we can see the IP address right here. But how does it work for this client to speak to the SMTP server or the web server? If I asked you for your favorite websites, you would probably give me the domain names of your favorite websites. Or if I asked you for your email address, you would give me something that looks like this. You wouldn't give me an IP address. Lucky for us, there is a protocol that exists which will translate these domain names into an IP address. And that protocol is DNS, or the Domain Name System. DNS will use a DNS server to convert a domain name into an IP address. The way it works is when you type in a website into your browser is first going to make a request to a DNS server asking for the IP address of the website that you just typed into your browser, and then the DNS server will provide an IP address, and this will now allow your host to make a request to the actual web server IP address, even though you never provided the website IP address itself. Your computer was able to figure it out automatically by using the DNS protocol. DNS is also what makes email possible. Again, if I were to ask you for your email address, you'd probably give me something that looked like this and not the actual IP address of your email server. But DNS would resolve this into your actual mail server's IP address, and now your client can actually send mail to the mail server. So as you can see, DNS is actually a pretty important protocol in the internet ecosystem. And in fact, DNS does so much more than what we just described. But discussing the full depth of DNS goes beyond the scope of this particular module. We will cover DNS in more detail later on in this course. Now let's go back to focusing on this host for a minute. Anytime a host connects to a network, there are 4 items that need to be configured on this host to achieve internet connectivity. And I'm going to show you those 4 items in this box. The first of those items is an IP address. This is going to serve as the host's identity on the internet. And this host right here has the IP address 9.1.1.11. The next thing a host needs is a subnet mask. This is going to tell the host the size of its network. This will allow the host to determine if it's trying to speak to something on its own network or to speak to something on a foreign network. Now a subnet mask can look like this, /24, or can look like this, 255.255.255.0. Both of those are simply different ways to display an identical subnet mask. Either way, if all a host has is these 2 things, an IP address and a subnet mask, this will absolutely allow this host to speak to any other hosts on the same local network. But if this host needs to speak to something on a foreign network, for instance, the internet, that host is going to need a router. And specifically, that host is going to need the router's IP address configured as that host's default gateway. With these 3 elements configured on this host can now speak through the router to the internet to any server using its IP address. But most of the time, when you're on the internet, you're looking at websites or trying to send email. And as we described a moment ago, you can't speak to domains without converting those into an IP address first, which means the 4th item that every single host needs in order to achieve internet connectivity is the IP address of a DNS server so that it can translate domain names to IP address so it can then communicate with other hosts using their domain names. These 4 things must be configured on every single host anytime it connects to a network. As we alluded to a moment ago, the definition of a host is anything that sends or receives traffic on the internet, which means a host could very well be your laptop, or your printer, or your mobile phone. In all cases, every time any of these devices connects to a new network, these devices must be configured with these 4 items. But some of you might be thinking, wait a minute, every time I connect to a new Wi-Fi network at the local coffee shop or the hotel or an airport or my school network, I don't have to go into the settings of my phone and configure these things manually. Yet I can still reach the internet. Well, what's occurring behind the scenes is yet another important Internet protocol. And that Internet protocol is known as DHCP, the Dynamic Host Configuration Protocol. What DHCP does is it allows a DHCP server to provide an IP address, a mask, a default gateway, and a DNS server for any client. This is actually what happens every time you connect to a new Wi-Fi network. Your host will send a DHCP discover message to discover the DHCP server, and then the DHCP server will provide these 4 things in response back to the client. Then your client has everything it needs in order to speak to the internet. And that is how every time you connect to a new Wi-Fi network, your phone or laptop automatically acquires the information it needs in order to speak to the internet. And that wraps up the main ideas I wanted to communicate to you in this lesson. The main takeaways of this lesson is understanding DNS and DHCP and their roles in internet communication, understanding the 4 things that every single host needs in order to attain any sort of internet connectivity, and understanding a high-level definition of each of the other protocols that we discussed in this lesson. For each of these, we really only scratched the surface for what those protocols do. We could spend hours talking about each of these and how they work. But for now, I just wanted to give you a quick idea of where each of these protocols fit into the overall internet ecosystem. Either way, that wraps up this lesson. I hope you enjoyed this video. I want to thank you for watching, and I'll see you in the next one. Hey YouTube, I hope you enjoyed that free lesson. I'm releasing this content for free to see how much interest there would be in a full Networking Fundamentals course taught in the same practical networking style. If you want the full course to be created, you have to help me out by spreading the word about this free module. If this content gets enough attention, I will definitely create the full course based upon your suggestions for what you want in a Networking Fundamentals course. Besides, I'm sure you know someone that would also benefit from learning how data flows through the internet, so you'd be helping them by sharing these videos. You could also further help me out with the YouTube algorithm by liking, subscribing, and leaving a comment below. I would appreciate it greatly, and I read and respond to every comment. Otherwise, feel free to join fellow learners and fans of practical networking on Discord. The invite is available at pragnet.net/discord. Thank you for watching, and we'll see you in the next video.